Hello, my name's Eamon Malloy. I'm the Head of Design and Technology at Bootham School. One of the questions that most people will ask me when they're thinking about studying A-level Design and Technology is, what careers can I have with D&T? In DT, we have a display board that I could have filled 10 times over of the type of careers that people decide to do who've studied A-level Design and Technology. But we'll just briefly talk about a couple today. Sophie, for instance, up here, she went off to Brunel University and she studied industrial design, and she now works for a major pharmaceutical company where she designs the little units that are used in, say, asthma inhalers or other devices that allow people to inhale or inject drugs into themselves. Quite an unusual job. This student here, Anna Robinson, went on to become a mechanical engineer, and she works for a company now in the northeast, and she builds and designs bridges. Tony Wu, he studied engineering and engineering design and at Imperial College, I think that was, and he went to work for James Dyson. And when I found that out, I got very excited and I asked him whether he could go and take some photographs of what he was doing. He said, no, if I take photographs, I'll end up getting sacked. It's all top secret, so he's not allowed to talk about that. The Russell Group of universities do produce a booklet which talks about some of the subjects where A-level Design and Technology would be helpful. And so, for instance, we've got architecture, aeronautical engineering, art and design, civil engineering, electrical, general engineering, materials science, mechanical engineering, and of course teacher training. And that's not just the list. There's all sorts of types of interior design, product design that you could find very helpful to have A-level Design and Technology. The exam is 50% of the course, and that's 1 2.5 hour exam. And I won't waste your time today talking about what the content of the exam is. You'll receive documentation on that, and then you can read that at your leisure. But, and this is very important, 15% of that exam is maths-based. You are required to have a good GCSE in maths to do this course. You will be expected to demonstrate the application of maths in designing technology in a variety of different ways. I'll send a booklet with this presentation, and in there will be some examples of the types of maths questions you would be expected to answer at A-level. And this will give you a general feel of what would be required of you so that you can make an informed decision. Coursework is 50%. You choose a problem to solve, you solve it. And that's done over about an academic year. I often show this picture to people when they're first starting their design projects. It's not about what you want to do. It's about fulfilling the needs of the user, making sure that you produce a design that suits the user, not something that you want. And you need to get into that mind frame. If you're planning on doing A-level, it's about solving problems for other people, not for yourself. I'll quickly show you some A-level projects to give you a flavour of the type of thing that we do. But I don't want you to think the coursework is all about making. Some of it is about making, but there'll also be quite a detailed design folder to produce. As part of this presentation, I'll also send you some examples of grade A-star folders that you can flick through and give you an indication of what sort of level you'd be expected to work at in order to get an A or a high mark. This one I really like. This student here, he went to his local primary school where his little brother goes, and one of the problems they had was with the storage of equipment, sports equipment outdoors. So he came up with this fun mobile unit for storing sport equipment. Perfect sort of A-level project, solving a problem for somebody else. This is a adjustable art easel. This is a rather innovative adjustable lamp. This is the student who went off to work for Dyson who designed this. This is a lovely example of innovative thinking, flat pack furniture, cheap slot together furniture. Another art easel, folding adjustable art easel. This is a super project that was for the junior school. This student went down there and had a chat with people at the junior school, with some of the music teachers. And the idea was that they wanted to have a unit, a product that went outside so children could experiment and play music outdoors, somewhere to sit, somewhere to play. Lovely project. This is an interesting one where the student can, the child would ride on a trike, but as the child got older, you could dismantle the trike and put it back together to turn it into a balance bike. Again, flat pack. Just another little element of innovation thrown in there for good measure. Music speakers that can be adjusted, quite a fun one that, and quite an innovative little bit of art storage. This is a device to go in the garden for compost, folding device. It's to encourage children to get out in the garden, have a bit of fun in the garden. There's an area there for storing tools and such like. This student went on to work for quite a well-known company, Seymour Powell Designers in London. She travels all over the world now as a designer. Very elegant piece of work. Bike stand. Flat pack storage unit, cheap storage unit for storing books and such like for a student. And I particularly like this one because I want to get across this idea that, big isn't always best. It's demonstrating a little bit design innovation is the important thing. You'll hear me talk a lot about in this course about design innovation, not copying ideas, but coming up with your own new ideas. And this one is to be able to turn a motorbike round in a small space in a garage. Not particularly large project, not particularly complicated, but a project that solves a real problem. So he did well and got a good grade for that. And he went off to Brunel, I think, to study product design. Okay, I hope that gives you kind of a flavour of what we're going to do. Yes, you will design and make things. Please look at those folders so you've got a really good idea of what I'm expecting of you. You will be required to do some maths. Like it or not, it's part of the course. You can't do design and technology without being able to understand how maths plays a part in technological things and the solving of technological problems. Really important aspect of DT. And I'd like to finish with this video, which I think sums up really well what we're trying to do in terms of design, innovation, demonstrating imagination, demonstrating creativity, solving a real problem. Thank you.
A while ago, I designed a chopping board that folded into a shallow bowl. But I wanted more, so I decided to revisit the project. Some initial ideas as rough models showed promise, others not so much. I arrived at a solution and built this prototype in plywood. A member of my family saw the design and commented that they thought it would make a good wheelbarrow. So, with a bit of tweaking, I built a rough model, which is still in development.